Synthetic division, example problems. So we're on 3-4, day 2. Here we go. So just to get started, I want to clarify something. If you see this, x cubed minus 8x squared plus 17x minus 10 divided by x minus 5, don't be thrown by that. It's the same thing as this. So don't get used to one way or the other, but this is probably more comfortable because it's clearly divided by this. So I could go, aha, cheap monkness, what minus 5 is 0? 5. Take my coefficients, a 1, negative 8, 17, negative 10. So I hope you understand these are just the same, okay? Make your line, drop the 1, multiply, add, multiply, add, multiply, add. Is that my answer? Kind of. You go to the highest power, and you go drop down 1. So that's 1x squared minus 3x plus 2, no remainder. So there's my answer. Remainder 0 if they ask you for it. Okay, there's your warm-up. Now some new stuff is coming. Okay, so there's going to be some problems in this next assignment. They're going to give you a problem like this, and they're going to say, hey, what's the remainder? And yeah, you can go through this whole process and figure it out, and that'll work. It's not the end of the world. But there's a theorem that says if you take this number that goes in your cheat monkness, now remember what the question is. The question doesn't really care what's the answer. They want to know what's the remainder. And there's a little trick. It's not a big deal. It just works. You take the number that goes in your cheat monkness. In other words, what causes this to be 0? 5. And all you're going to do is you're really going to go f of 5 equals, and you're going to plug it into this. So you're just going to go x cubed minus 8x squared. Am I still on the board? Barely. Plus 17x minus 10. Am I still on there? Yes. A little blurry, but I think you'll make sense of it. So if I take this and I plug it in here, this is just going to give me the remainder. I'll prove it to you. 5 cubed is 125. 5 squared is 25 times negative 8 is negative 200. 17 times 5 is 85, and then minus 10. Now look, if I add the negatives together, I get negative 210. If I add the positives together, I get 210. Guess what? That equals 0, and that takes me right to the remainder. Now, what's easier? That's for you to choose. So don't forget, you can just use this method, or you can just take that and plug it in to the original numerator, and it will just spit out the remainder. It just works. It's called the remainder theorem. There's more to it. I got to hit pause. All right, so here's the same problem kind of introduced to you slightly different. So it's saying, hey, is x minus 6 a factor of this? In other words, if I was to divide this by this using long division, synthetic division, would I get remainder 0? If I get remainder 0, then yes, it goes into that evenly. Just like 27 is 3 a factor? And the answer is yes, because 27 divided by 3 is 9 with no remainder. Is 4? No. It goes into 27, but then I'd say, oh, it goes into 27 6 times with a remainder of 3. Because it has a remainder, it's not a factor. So with that being said, we're going to use the shortcut. This is actually like this. And we'd say, aha, what causes the denominator to be 0? 6. Now that's what I would put in the cheap monkness if you wanted to use synthetic division and figure out if there's a remainder or not. But all we're going to do is use the remainder theorem, plug 6 in for every value, 6 to the 4th minus 8 times 6 cubed plus 16 times 6 squared minus 23 times 6 plus 6. Now I'm going to do my math and then put it on the board so I don't waste your time. Okay, so got my calculator out. 6 to the 4th, boom. 6 cubed first times 8 with a minus in front of it, boom. 6 squared, 36 times 16, boom. 6 times negative 23, that 6 comes along for the ride. I boxed my positives, and I got 1,878. My negatives are here, so I added my negatives and got this. Subtracted them, and I got a positive 12. You know what that means? It means I have a remainder of 12, which means nope, x minus 6 does not go into that evenly. That's it. All right, let's keep this train moving. There's going to be a few homework questions that are going to rephrase things. And as a math student, you're like, oh man, it's just throwing me the instructions. So if you just take these instructions, just face value, follow it, can't go wrong. But there's more to it, so I'm going to explain that. It says if x equals 4, evaluate the polynomial. So it's like, okay, f of 4, which means plug in 4 for x. So I get 4 to the 5th minus 3 times 4 to the 4th minus 2 times 4 cubed plus 4 squared minus 2 times 4 minus 1. Once again, I'm going to hit pause, figure this out. So, did all my math. 4 to the 5th, 4 to the 4th, 4 cubed, 4 squared. So I plugged them all in, and I got my positives here, added them together, added all my negatives together, got this, and here's my answer. So on face value, my answer is 135. What I want you to understand is, if they said this problem in a different way, if they said, is x minus 4 a factor of all of this, then you'd go, hey, what causes that to be 0? 4. Then you plug 4 in, ding, 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 just like you did. You get a remainder, and then you say, no, it's not a factor. So this is just a straightforward question, but really what's disguised is they're asking you, does x minus 4 go into that? It's the same question, just kind of worded differently. They just flat out tell you what to plug in on these. On these, you have to ask yourself one question: what causes that to be 0, 4, then plug it in. Same question, presented a little differently. So be prepared for that. One more sample problem. Okay, grand finale. As you can see on the board, I'm taking this from page 157 in your textbook from example 4. So I've kind of condensed it, but it's a problem about tortoises and their growth. So they kind of explain it this way before I get tongue-tied. It says the population of tortoises on an island is modeled by the function right there, where x is the number of years, here we go, since 2015. So this is the starting place. Now they're saying estimate the population in 2023. The reason they say estimate, with population growth, we never can be precise. So that's the reason why they use that word. Don't let it throw you. So here's a value of synthetic division, kind of a life application. This is an equation that describes the growth of tortoises. Imagine that. If I look at this and I say, hey, how many years? That's 8 years. Notice, x is the number of years since 2015. So I'm going to take that, and that's what I'm going to put in my cheat montnaise, and that's going to determine, so what I'm really doing is I'm finding P of 8. In other words, if I put an 8 right in here, and so I plug it in here, 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 and that will produce the value of that polynomial function, slash number of tortoises in this situation. So here we go. I'm going to plug it in, -8. Oh, I don't want to confuse you. We're not using synthetic division. We're just plugging it in. So 8. Oh, I'm sorry. Boy, getting tongue-tied in my brain. So I got a negative there, but it's negative x cubed plus 6 times x squared plus 12 times x plus 35. So I don't want to screw this up, so I'm going to get out my handy dandy calculator. So as a teacher, sometimes it's really good to be transparent, and I'm afraid I have to be really transparent right now. I was about to put that in the Chipmunk nest, and that would have been the correct thing to do. And then I just thought about it differently, and that's inappropriate. Because if I do all this math, I end up getting something like two tortoises. That's when I'm like, I don't think so. So that's where math kind of has a safety net. It just doesn't make sense. So then I thought, wait a minute, we're talking about the remainder theorem. So if I follow through on this problem and I actually put the 8 in the Chipmunk nest like I was gonna, then I take -1, 6, 12, 35, drop the -1 down, boom, boom, -8, -2, -16, -4, 32, -32. Oh my gosh, did I screw up again? I might have written something down wrong. Well, you get to watch a math teacher just fall on his face. I think it's healthy. Yeah, if you notice, I wrote that number down wrong. That's supposed to be 325. That's why my techniques were not working. This is the technique they use in the book, which is easily fixable. But now I know that this is not 35, it's 325. Jeez. And so now 8 times -4 is -32. And now I don't trust myself. Okay, so here we go. Grand finale. Try to close this wonderful example problem up. I just want to be done with it. So I wanted to show you that, again, 8 years, put in the Chipmunk nest. You can follow the whole process if you write your numbers down correct. And I get 293. Now the remainder is the number of tortoises based on this situation. But if I would have gone with my other idea, with the right information, I would also get 293. So you can use synthetic division to get the remainder, or you can just use your remainder theorem and just plug that value in, which is the shortcut version for sum. I don't know if that's necessarily a shortcut. I don't know which one's easier for you, but you can see they both work. Got it done. Persevere.